Hello all, welcome to AI Educator. In this video, let us learn how to create ANN sequential model on iris dataset. First, let me import the required libraries. I'm importing NumPy and I'm giving it an alias as NP. I'm importing pandas. I'm giving it an alias as PD. Now, from sklearn.datasets, I'm importing iris by writing load underscore iris. The iris dataset is present in the sklearn library datasets. Okay. Now let us import the train test split from sklearn. From sklearn dot model selections, model underscore selection. We'll import train underscore test underscore split. Now from tensorflow.keras, I'm importing sequential, and from tensorflow.keras.layers, I'm importing tens. That's it. These are the required libraries. Now let me run this cell. All the libraries are imported. Now let us load the data. In order to load the data, all you need to write is data is equals to load underscore iris and run the cell. It's done. Now let us create a data frame. df is equals to pd.dataframe of inside data.data, comma columns is equals to data.features underscore name underscore names. Now I'm telling df of target is equals to data of target. Let me run this cell. It's just feature names. Let me run this again. Yeah, it got loaded. It's done. Now let us check the head of the data frame. df.head. Let me run this cell. Now as you can see, we got a data frame with 5 columns: sepal length, sepal width, petal length, petal width, and target. Now let us explore the data set. First, let me print the data frame. So this is the entire data frame. Okay. We have 0 to 149, which is 150 rows and 5 columns. Okay. Now let us see the column names with df dot columns. You can see there is sepal length, sepal width, petal length, and petal width, and target. We have 5 columns. Now let us check the info. df dot info. Here we have no null values, and the sepal length, petal width has a D type of float 64, and target has a D type of int 32. Okay. Now let us check the unique values in the target with df of target dot unique, and you can see here we got 3 unique values 0, 1 and 2. Here 0 represents the iris setosa, 1 represents the iris versicolor, and 2 represents the iris virginica. Okay. Now let us split the data into x and y. In order to do that, all you need to write is x is equals to df dot drop of target, comma axis is equals to 1. I'm taking all the columns in the data frame except the target. So I'm dropping the target from the data frame. So I can get sepal length, sepal width, petal length, and petal width into the X. Now for Y, I'm telling df of target because this is our target column. We are only taking that one column into Y. Now let me run this. Yeah, it is done. Now let us encode the targeted data. Okay, in order to do that, all you need to write is y is equals to pd dot get dummies, get underscore dummies, and inside y, it is done. Now, why we're doing encoding, it will help us to create a new columns. Let us take a small example so that we can understand it better. For example, we have a column called color and it has three unique values inside it, which is red, yellow, and green. Okay. And when we apply the get dummies on this column, it will create three columns of three unique values which are present in this, which is red, yellow, and green. And for every record, it will check whether it is present in all the columns. Now, if red is present, it will give 1 for the red and remaining 2 will become 0. Similarly, when the record has yellow, it will give 0 for red and green and 1 for yellow. In this way, it will create three new columns. Since we are doing multi-class classification, I'm making get dummies of the target label, which will also create three columns, which column names as 0, 1, and 2, where 0 represents the iris setosa, 1 represents the iris versicolor, and 2 represents the iris virginica. Now let us see how to split the data into training and testing. In order to do that, all you need to write is x underscore train, comma x underscore test, comma y underscore train, comma y underscore test is equals to train underscore test underscore split of x comma y, and I'm specifying a test underscore size is equals to 0.2. Now this will split the data into training and testing part. Yes, it is done. So now let me explain what we have done. First, we have divided our entire data set into features and target. X is our features and Y is our target. Now we have divided the data set into two parts again for training and testing. The ideal ratio for training and testing is 70-30. Since I have a small data set of only 150 records, I'm taking 0.2, which is 80-20 percentage. This test size will define how much to split. Okay, so I have taken here 80-20 percentage to split the data. Okay, once we split the data, we will get X train, which is the features present for training, and Y train, the labels present in the target column. Okay, and X test, the features for testing, and the labels present in the target column for testing. We separate them with a ratio of the test underscore size. Okay, once we do that, next we'll give the X train and Y train to the model, and the model will get trained on it and it will generate its own rules. Okay, once our model is well trained, we'll give unseen data, which is X test, to the model, which gives us the predictions Y pred. We already know the expected results Y test, so the difference between the Y test and Y pred is our loss. So this is how we train in neural networks. Now let us build the model. We can build two types of models. One is sequential model, another is functional model. In this video, let us create a sequential model. To create a sequential model, all you need to do is to write model is equals to sequential and a parenthesis. Now let us add the different layers to the model. To add it, all you need to write model dot add, and inside a parenthesis, let us create the dense layers, dense, and here you need to specify the number of nodes. Okay, I'm telling 8 nodes, and I'm giving an activation as ReLU, and I'm giving the input shape, input underscore shape is equals to inside a tuple. I'm telling 4 comma. Since we have 4 columns, sepal length, sepal width, petal length, and petal width. Okay, since we have 4 columns, I'm giving the input shape as 4. Now let me add the hidden layers. Model dot add tens, and I'm taking 10 nodes, and I'm giving an activation as ReLU again. Now let me add another two. Let me add another 2 hidden layers. Model dot add dense, and again I'm taking 10 nodes and activation as ReLU. Model dot add dense with 10 nodes and activation as ReLU. Now let us add the output layer. Model dot add dense, and here the number of nodes should be equals to the number of classes that we are classifying. Since we are classifying 3 different flowers, that is Iris setosa, Iris versicolor, and Iris virginica, I will view the number of nodes as 3, and I'm taking an activation function in the output layer as softmax because we are performing a multi-class classification. Okay, so I'm taking 3 nodes with an activation as a softmax as my output layer. Now, in order to create the model, all you need to do is to run this cell. Our model is created. Let us check our model summary. Model.summary. Now let me run this. See, this is the summary of my model. First, I have given a dense layer with 8 nodes and it has 40 parameters. And the second layer with 10 nodes, which has 90 parameters. And the second hidden layer, again with 10 nodes, here it has 110 parameters. The third hidden layer, which also has 10 neurons and it has 110 parameters. And the last layer is a dense layer with 3 neurons and it has 33 parameters. In total, we have 383 parameters and all of them are trainable parameters. Now, let us compile the model. In order to compile the model, all you need to write is model.compile, and inside a parenthesis, we'll give 3 parameters: optimizer. I'm taking an optimizer as Adam, and I'm taking a loss function. Loss is equals to categorical cross entropy. Categorical underscore cross entropy. And I'm taking an evaluation parameter. Metrics is equals to accuracy. The compiler will assign 3 parameters to the model. It will tell which optimizer to be used, which loss function should be used, and which evaluation parameter should be used while training the model. It's done. Now let us train the model. In order to train the model, all you need to write is model.fit. Inside the fit, we need to give the xtrain and Y train and the number of epochs. Here I'm taking 100 epochs. Now, why we are giving X train and Y train here? Since we have learned here that we need to give the X train and Y train to the model, it will train and it will generate some rules. Then if we give the unseen data X test to the model, it will give us Y predictions. Okay. So here we have given the X train and Y train to the model. And since I have a small data, I'm running it for 100 epochs. So let me run this cell. See, you can see the epochs and here is the loss which is reducing and this is the accuracy of my model which is getting increasing. Okay. At the 100 epoch, I can see this is my training loss and training accuracy. My training loss is 0.5 and my training accuracy is 0.85, which is 85% accurate. Okay. So now let's evaluate the model. To evaluate the model, only need to write as loss comma accuracy is equals to model dot evaluate, and inside this we need to give the X test and the Y test. Now let me run this cell. Now let us print the accuracy. So we got a test accuracy of 89%. Now let us make some predictions. I'm taking a list L1 is equals to, here I'm taking the values of iris setosa and see whether our model predicts it as iris setosa or not. So 5.1, 3.5, 1.4, 0.2. So these are the values of sepal length, sepal width, and petals of iris setosa. Let us predict. Let's say R1 is equals to model.predict of L1, which is our list. And let us print the result. The argmax, since we are taking the softmax as activation function, we will get the probability. So let us use the argmax function. np.argmax of R1. Now let me run this cell. Yeah, I have taken the setosa and it is giving me the value of setosa. This is how you create ANN model on structured data such as iris. In the next video, let us see how to create the functional API on the iris dataset.